Hello, well, it's the start of March, and therefore it's the first Sunday in March in particular, and therefore time for NTSAN number 3. So apologies from Chris Lintott this week, but I'm joined by Lucy Green, and we're hoping to have Pete Lawrence with us as well. We had some technical difficulties, so he's currently not with us at the moment, but fingers crossed he'll be back before the end of the hangout. So I guess, Lucy, it's been an exciting month, or particularly this last week's been exciting, hasn't it?
It has. Well, for me and for many other people around the UK, this week was fantastically exciting because we got to see something very rare, and that was the display of the aurora down into the south of England. Now, I didn't manage to see it, I'm afraid. Where I live is far too light polluted. I don't know if you got a view, Chris.
No, I didn't get a view. Too light polluted down here in Cardiff, and also a little bit too far south. Although people around South Wales and this sort of latitude did see it, so I obviously didn't try hard enough.
Yeah, it was an interesting one because when I first heard that the aurora was being seen, I didn't think that the aurora is formed by geomagnetic activity, and I wasn't expecting that an auroral display would be formed for the level that we saw. It wasn't that big a geomagnetic storm. But I think what was interesting is that so many people are now getting out with their cameras and doing long exposure images that actually we're picking up the display with the cameras more than the human eye. And then, of course, they get sent around on social media. Oh, I see Pete's joined us.
Hello.
You're very quiet again, Pete.
Am I very quiet?
So I thought it might be worth saying a bit about how the aurora form, because there's lots of discussion about, okay, we know that the sun is the origin of the energy that creates the northern lights, but how in particular does it form? And I think there's one sort of misconception that quite often gets talked about, which is that it's solar wind, so this flow of charged particles and magnetic field from the sun that heads out into space and then collides with the Earth's atmosphere. And I wanted to show a couple of images that one of my colleagues, Chris Arridge, makes at MSSL to sort of introduce us to what's happening. So this one here is an image that shows a sort of cross-section of the Earth and its magnetic field. And you've got the sun on the right-hand side, and the solar wind is then rushing in and hitting the Earth's magnetic field. And you can see that it's squashed up on the sunward side and it's really stretched out on the night side. And I wanted to show this image because it really illustrates that the solar wind can't get to the Earth's atmosphere. So you can just see the Earth is, I'm not sure if my cursor is showing here, but the Earth is this tiny sort of blue and yellow spot down here. So that's where our atmosphere is. But the solar wind comes in and gets deflected around the Earth's magnetic field. So it can't actually directly reach our atmosphere. We have this sort of natural shield. And
the
so then
particles themselves can't get here. So all these particles, this a billion tons of matter moving at 1,000,000 miles an hour, they don't actually get here.
No, only on very, very rare occasions, because they need to punch a hole through the magnetic shield, and that does sometimes happen, but it's not like the flow can just directly impinge on our atmosphere. And the kind of image that I also like to show is one like this. Okay, so this is the same sort of image now. So again, this is made by Chris Arridge, and I sort of flipped it a bit so the sun is now sort of behind us and you're looking at the Earth and the Earth's magnetic field. But what's nice is that Chris has colour-coded different sections of the Earth's magnetic field, and they illustrate where we find high-energy particles, much, much higher energy than those that come in with the solar wind. And it's actually these particles that are already trapped in the Earth's magnetic field that for some reason get accelerated and come down into the Earth's atmosphere, lighting up the gas at the top, so the oxygen, the nitrogen, making it glow to form the northern lights. So it's acceleration of particles already in our magnetosphere that does the job. Okay, what's the sun got to do with it in that case? Well, last week what we had was a coronal mass ejection that left the sun on the 25th, got here on the 27th, and it put energy into the Earth's magnetic field, which then led to the particles being accelerated. So the sun still plays an important role, but the particles themselves that create the northern lights come from our own magnetic field.
And Pete, I know that you spent the last the last week basically living and breathing the Northern Lights. So have you got an image, I believe, to show us that I think is or should be on screen at the moment?
Is it on my screen at the moment? That's Peak Glastonbury, a fantastic picture of the rural storm that occurred on the. I've lost my dates because I've been flying over the last nine days.
27th.
7 times. I've got the 27th.
Yeah, 27th, 28th.
Yeah, okay. But it's a fantastic picture, and it shows very nicely that lovely green hue from oxygen being accepted at the bottom there, and the lovely reds and purples on the top. Now that red bit on the extreme left of the image is the bit which I think was most prominent for a lot of people in the UK, because the green dropped below the horizon. So what most people saw was that sort of reddish glow. And I know there was a photograph from Darren Baskell, I believe, from Brighton, that managed to pick up the red from there. So it was visible a long way down the country. And it's also worth saying, perhaps, that the active region which generated or was responsible for the CME that actually came off is the same one that generated the CME when I was up with Liz Bonin doing the Stargazing Live Aurora Hunt. So that was, in those days, it was AR 1944, and then it came round again and became AR 1967, and now it's AR 1990, so it's been around 3 times.
And Pete, is it common for sunspots like this to come round again, to see them time after time?
A big one will persist for a while, but we haven't had a big one like this for ages, have we, Lucy? I mean,
No.
A bit black, to be honest.
Yeah. And there's something. Sorry to interrupt. There's something for amateur astronomers, I think, to look out for, and that's the formation sites of sunspots. And if you monitor the sun over time, so really week to week, month to month, then you see that new sunspots tend to form in the location of either pre-existing or old sunspots. So if you can sort of work out a grid on the sun of longitude and latitude, you'll see there are longitudes that are where sunspots preferentially form, and Cassini observed this in the early 1700s, and they got called active longitudes or active nests. So it may be that in that long-lived region, Pete, that you're talking about, that actually there was new magnetic field forming and new sunspots forming, as this thing has been rotating around the sun.
And presumably this is because they're magnetic phenomena, and so that magnetic disturbance, if you like, that's just below the surface of the sun or on the surface of the sun persists and generates new ones. Is that the thinking?
Yeah, so it's something to do with processes happening about 1/3 of the way into the sun, and for some reason, you're right, new magnetic field keeps rising up from the solar interior through the surface and into the atmosphere. I'm not sure it's fully understood really why you would have preferential sites. It's due to mechanisms happening inside the sun where it's hard to make observations. Okay, we do because we have the technique of helioseismology, but I'm not sure that models would reproduce that kind of activity. But I think it says something about the fact that the magnetic field evolution inside the sun isn't a symmetric evolution. There's regions where it's stronger and regions where it's weaker, and the regions where it's stronger is then where you get this flux emergence, we would say, in the formation of sunspots. So that's a beautiful image there. I mean, there the sunspots look quite spread out over the surface of the sun, but if you monitored over time, you would see actually there's certain longitudes where you tend to see repeated formation of sunspots.
And Pete, this is one you took recently, is it?
Yeah, it's one I took yesterday. And the active region, which is AR 1990, you see I don't know if you can't see my cursor, right? But you've got the 3 main spots which are over in the left side of the sun's disk there. AR 1990 is the right most of those 3, so the one above the other 2. Does that make any sense? Yeah, I think so. But that's it. But there are actually quite a few patches of sunspot activity now, which is quite nice. I mean, we've been through. Have we been through solar maximum? I think we have, haven't we, Lucy? And it's been pretty.
I think we probably have.
In terms of sunspots.
It has been. It's been disappointing. And another thing that's interesting about that region is that, so like you say, it was on the edge of the sun from our perspective when the CME left. And even though the model said the eruption would reach us, it said it would give us a glancing glow. I didn't believe that it could drive such a strong response at the Earth. And I think it just goes to show that you have got to be monitoring the sun all the time, because even when you least expect it, or when you least expect it, the sun can still have a really strong effect on us.
Well, I think we can move on. We should probably move on to other topics besides the sun. But before we do, we should obviously answer a question or two. So we've got one come in, I believe, from Bill Irving, who says, do all CMEs, coronal mass ejections, go at the same speed, or is there a variation? My 8-year-old was asking me after the display, and I couldn't answer her. Oh. So Lucy, can you answer Bill's question?
Lovely question. So, and actually with, they are, excuse me, it is interesting to look at the speeds of these eruptions. So when they leave the sun, they can be traveling with speeds of between, well, from as low as 100 kilometers a second. Okay, that probably doesn't sound very low, but the top speeds can be maybe up to 3,000 kilometers a second. But what's really interesting is that by the time they reach the Earth, the slow ones have sped up and the fast ones have slowed down. So their speeds when they get here are around 400 kilometers a second. And the reason that they speed up and slow down is because there's also this flow of the solar wind, and they interact with that. And the slow ones get swept up, and the fast ones sort of get dragged and slowed down. It's a really good question.
It's quite a complicated thing to actually do the prediction. There's lots of different models that come when the CME, which don't always in terms of the time of arrival.
Yeah, the models do give us a wide time range at which the CMEs arrive, plus or minus, I don't know, 12 hours or so.
And I guess that's because you don't know what is between the leading edge of the CME and us, because you've only got like pace way monitoring the solar wind, but there's not a lot.
No. No, so you have to have a model of what the solar wind's doing, and that may or may not be accurate. You're still a little bit quiet there, Pete.
Sorry, I lost my video as well. I think it's my connection here that's I am still.
Well, we can still hear just about what you're saying. I think so. That's all good. Well, we should move on to what's coming up in the future, I suppose, in the coming weeks. So. Pete, do you think you could give us your rundown of what's to look for in the coming weeks in the night sky?
Yeah, sure. You haven't got my video, but you don't need to see my face. You know I exist. I think the first or the main thing to look out for in March is on the 16th, when there is a transit or shadow transit on Jupiter. So that's when two moons will cast their shadows onto Jupiter's disk, and the shadows will appear at exactly the time on the disk simultaneously. Ganymede's shadow will cross Jupiter's disk at about 2200 hours on the 16th, and Io will follow about 20 minutes later. So that's something to look out for, because you get single shadow transit where a moon will cast a shadow on the disk quite often. But to get a double one is less common, and to get a treble one is really uncommon. There's one of those coming up in the middle of the year as well. But we should also mention that on the 20th of March, it's the X is with us. So that's the time when the centre of the sun crosses the solar equator. So it's moving from the southern hemisphere to the northern hemisphere. Now that has a knock-on effect, because that gives us the fastest rate of change of or the change of the length of daylight that we get throughout the year. Now that beautiful constellation of Orion, which hangs there so magnificently, or it has been hanging there so magnificently over the last few weeks, will rapidly disappear from view as it heads towards the west every evening, moving slightly further to the west at the same time in consecutive nights. the increase in daylight, the twilight coming up, just engulfed the constellation. So if you like Orion, get a good look at it now, because it won't last for much longer. On the 21st, the moon will be 1 degree south of Saturn, so that's something else to look out for, and that's quite a nice thing to pick up. It's a nice thing to try and photograph, and there's some interesting things happening with Saturn later. I believe it's in October. The moon will actually in front of Saturn, so this is a good time to try and get your photographic skills together to actually image the two objects together in the night sky. Venus is at its greatest western elongation on the 22nd of March, and that's visible in the sky before sunrise. But Venus, like Mercury's in the morning sky as well, are not well placed at the moment. They're quite low down. What else are we going to talk about? On the 31st, there is a chance to see a very thin waxing crescent moon as well after sunset, and I love hunting those really thin crescent moons as the sun's gone down. That's quite a challenge to pick those up. If you miss it on the 31st, then as you head into next month, the will get bigger and bigger, of course, and you get some fantastic crescents at this time of year because they're well placed. They're high up in the sky after the sun has set. That'll do for me.
Well, we've had a question about observing. So someone who goes by the name of an astrophotography magazine, I believe, asks, what are the dates of the meteor showers in March, please? So, Pete, putting you on the spot a little bit. Any meteor showers in March off the top of your head?
It's putting me on the spot a little bit. Major meteor showers in March that I'm aware.
I can't think of any.
Nothing particularly major happening in March. Can't think of it. No. I'll look it up. I don't think there's anything major happening in March. Interesting meteor shower which is coming up, which isn't fatal for us, unfortunately, is in a couple of months' time in May, where we have a new meteor shower occurring. But for March, more.
Okay, so not a great month for meteors. Now, you mentioned the moon at the end of that piece there about what's to come up, and there was a story in the last few weeks about something that's been going on the moon, which is impacts. And this is actually an impact. The latest one that's hit the news is an impact that happened back in September of last year. But this was an impact on the moon by a rock that, well, a small asteroid that was probably about 1 meter across, weighing about 400 kilograms, and hit the moon at something like 40,000 miles an hour, as space rocks tend to. And there's even a little video, which if I try and share my the appropriate video, I can hopefully get us back. So if I share, I'm just looking at the video that's on YouTube at the moment. Here we go. So if I play this video, then you should see a flash appear by the little blue arrow. There we go. So that was observed by an array of telescopes, or a collection of telescopes, constantly observing the moon back in, or all the time, and they saw that back in September on the sort of the Earth-shine side of the moon, the side of the moon that isn't lit directly by the sun, but at that time was lit by reflected light off the Earth. And it really shows that, you know, the moon is still things happening on the moon. This explosion, which is this impact, the largest one ever recorded, tells us, or can tell us a little bit more about the makeup of asteroids that are flying around. Of course, this type of asteroid, just 1 meter across, wouldn't have made it through the Earth's atmosphere. It would have burnt up. So that kind of thing is of no danger to the Earth. But the moon without an atmosphere was a sitting duck and got pummeled by it. So it's probably left a crater about 40 meters across. I haven't seen any reports of images from it, of this crater from the Lunar Reconnaissance Orbiter, which is orbiting the moon and taking very high resolution images all the time. But hopefully at some point some will come through and we'll be able to see what kind of mess this impact made. But there's always something going on, which is always good. And I guess we can also take a few more questions. So what questions have we got coming here? So Lucy, there's someone referring to the sun again, as you might expect, given what we talked about. So Damien Weatherly asks, what are the chances of another display like last week's, i.e. as far south as central England?
So these size displays are really probably once or twice every decade in their frequency. So I was thinking back in 2003, we had a really large sunspot on the sun that produced coronal mass ejections, and they did produce, I think, a couple of displays in 2003. I missed both of them, but I remember that there were reports in South Wales and in South England, and that was back in 2003 when we were at the height of the solar cycle again, and now here we are 11 years later back at solar maximum. So we might get a couple more if we're lucky this solar maximum, and then we'll be waiting probably several years. So sorry, now I've been talking. I've forgotten exactly what the question was. Sorry, what are the chances of another display like last week? So low likelihood, but not impossible.
You know what?
And Pete, you saw the one. I remember you said you saw images of it back in 2003. Was it that you saw some great images from down the south coast?
Yeah, that's right. I can remember going down to the beach and taking my camera down there and picking up some quite nice activity actually. So that was a pretty good one. But the spot or the active region which caused the one on the 27th is moving around to the central position of the sun at the moment, isn't it? So if it's, I don't know, it's still active. I've not been following it in much detail, but if it is active, it's moving into a much more geo-effective position. So if it does go off again.
Yeah. We're the sitting ducks then.
We'd be sitting ducks. Yeah. That one would have caused us a bit of grief, wouldn't it? An X 4.9.
I think so, yeah, because the larger the flare, the faster, normally I think the faster the coronal mass ejection. So, okay, the flare is this flash of light in the sun's atmosphere, but they happen at the same time and in the same place as these coronal mass ejections. They normally occur on a one-to-one basis in the big events, and the bigger the flare, it's just a symbol that there's more energy release. So the coronal mass ejection is faster and bigger, and everything happens in these big events.
That's quite an interesting point as well, isn't it? Because there's a common misconception that it's the flare which causes the CME, but that's not the case, is it?
No. So that they are related, but I wouldn't necessarily say that one causes the other. And well, if I was to say that, I'd be more likely to say that the CME causes the flare because of the way it stretches and distorts the magnetic field in the sun's atmosphere.
Now, speaking of flashes of light, we've had another question that's come in. Unlike last NTSAN, there's no bright supernova to observe tonight. Supernova 2014J, which, for those who aren't in the know, is the one that took place in the galaxy M82 a couple of months back, is fading in the visible band, but reports in other bands, gamma ray, X-ray, and radio, seem to show no detection. Why is that? And that comes from John Murrell. Well, to the best of my knowledge, then this was a Type 1A supernova in M82, which is the best model that we have. Is that this is a white dwarf star, the end state of a star like our sun, which has reached a critical mass and essentially exploded in a massive explosion, this supernova explosion. And what that means is that the light we see in the visible is essentially the radioactive decay of all the material that's been produced in the massive explosion. In the X-rays and radio, with most supernovae, you would see them from the extremely hot material around the star, and that's because most supernovae occur from the explosion of a massive star, many times the mass of our sun. This particular type of supernova, the Type 1A, because it occurs from this white dwarf star, there's not normally as much material around them, so the X-rays and the radio emission tends to be weaker, and you don't get such a bright signature. So I think that's why there's no detection in these other wavelengths, but I'm sure they'll still be monitored over time. I think there has been another recent supernova in M99, if I recall, but that's not as bright, is it, Pete?
The 2014 L, isn't it, that one?
Is that L now? Okay, yeah.
I think so, yeah.
Right, in terms of other questions, we can go back to return to the moon. So Stephen Brown asks, are most TLP, that's transient lunar phenomena, likely to be impacts seen from Earth like the recent one? Now, Pete, I don't know whether you can say anything about these transient lunar phenomena and what they may or may not be.
Well, when I was a lad growing up, the TLP was actually often described as being the bright or slightly reddish patches that people had reported on the moon's surface. But now transient lunar phenomena also cover these impacts which you get, the flashes which you can pick up on the dark side of the moon, or the dark portion of the moon. I shouldn't say dark side of the moon, should I? Or the dark portion, the night side, if you like, of the moon. So I think that's the area where most interest lies in trying to detect those flashes, yeah. And there's still a bit of controversy about the other type of event, the TLP event, with the brightening or the slight orangey glow around certain regions of the moon. Some people will swear by them, other people will refute them completely. But the flashes are a definite, they are impact flashes. I think it's quite an interesting part of astronomy, actually. It could be an interesting development in imaging, especially to try and pick up these things on an amateur basis. I know there are cameras constantly looking at the moon to try and pick these events up, but it would be nice to get an amateur network going to do that as well. And there's some for the planets. Jupiter, for example, any clear night you'll have people trying to image Jupiter, and I wonder how many impacts which don't leave a scar after they've impacted, they're just a bright flash, go unnoticed, because people will be processing their images and those flashes will be averaged out. It would be quite nice if the processing software was adjusted slightly so it could actually look for these anomalies. That would be, I wonder how it would pick up.
Yeah, it could be a great development in coming years if this kind of thing can be rolled out, as you say, in an amateur network observing this stuff. That would be fantastic. We've got a couple of minutes left of our half hour. In fact, about just over a minute. So one question that's come in is Pete Lawrence must have had a blinder of a week with the Northern Lights coming so far south. What would be a great week for the rest of the NTSAN team? So Pete, first of all, question to you: has it indeed been a blinder of a week for you?
I have flown. I work with a company taking people up to see the Northern Lights. We fly up to the edge of British airspace, and I've flown over the last 9 days 6 times, and we have had 4 bright displays and 2 weak displays. Our night off was the night of the big CME impact, which was rather unfortunate timing, but because that would have been amazing. But I also had a charity flight last night, and the conditions were not looking great when we left. But there was a condition in the solar wind, in the polar solar wind, which was good for us. And I had an inkling that was going to go the right way, and it did. And we got a fabulous display last night. So yeah, it's been a good week.
Excellent. Would there be any other type things that could happen to make a week better for you?
Sleep.
A bit of sleep comes from Pete.
Astronomers don't mean that.
Now, Lucy, what about for you? What would make a good week for you?
Well, I want to get out and do a bit of observing Jupiter for National Astronomy Week this week, and so I think some clear skies, to get my telescope out to do that, I think would be good. Excellent. So a few clear skies to do observing, and I mean, you mentioned National Astronomy. We haven't actually mentioned that yet. I can't believe we haven't. So National Astronomy Week is this week. So it started yesterday, the 1st of March, and runs through till the 8th of March. And there are lots of events going on all over the UK. If you want to find an event near you, the website to go to is astronomyweek.org.uk, and that will show a map of events you can find there.
And there's also some interesting challenges, observing challenges to try and measure the speed of light from observations of Jupiter's moons. And there's lots of information about that on the site. We probably don't have time to go into that here, but that's an interesting experiment to try and recreate from back in the 17th century, I think, was it, or the 18th century? I forget exactly.
1676.
That's the one, 17th century.
Yeah.
Recreating those measurements. And I suppose I should probably answer what would make a good week for me. To answer my share of the question. Well, I guess some exciting going on in the night sky that we can all look at. So things like a bright supernova is always good, but maybe one even closer, maybe a bright supernova in our galaxy that we can go and observe and get some fantastic pictures of it. There was one like that in 1987 in the Large Magellanic Cloud, which is close to our galaxy. So maybe something like that, even closer to home. Well, I think we're pretty much out of time now. Any final thoughts, Pete or Lucy?
Yeah, Chris.
Yep.
Just before you go, don't forget Mars. Mars is now starting to come up at a reasonable hour in the middle of March. It's about 9 o'clock-ish. It's above the horizon. And the way to locate Mars is to locate our old friend, the plough or saucepan, handle of it, and follow the arc round to that bright orange star, which is Arcturus, and continue the arc round, and you come to Spica, a bright star in Virgo, and Mars is right next door to Spica at the moment, and it's really quite stunning.
So if you're only going to see Mars, now is the time to start looking for it. Excellent. Lucy, any final thoughts?
No, I think just look out for the clear nights and get your cameras out. Look for some more aurora and join in National Astronomy Week.
Well, I guess for now that's it from us. So best of luck to everyone taking part in National Astronomy Week and to the whole of March. I hope everyone gets a clear view of Jupiter and Mars and a few of those other things that Pete mentioned earlier on. This will be up on YouTube after the broadcast, so you can watch it again. I guess this is now, that's 3 in 3 months, so I believe that probably makes it a regular occurrence. So I suspect that there'll be something going on. There'll be an NTSAN again at the start of April. So until then, thanks very much. Goodbye.
Goodbye.
Bye.